if we want to find the velocity function of this position function, first of all, this position function, again, a particle or something's moving back and forth basically along the x-axis. You could also make these so they go up and down. But in this particular one, we'll say it's going this way. If you want the velocity function, you just derive the position function. S stands for position usually. So we derive x to the third, or sorry, t to the third, because we're going in due to time. T to the third would be 3t squared. This one will become negative 40t. This one becomes 128. Okay. So, that right there is our velocity function. The next question is, when is the velocity greater than 0? Or when is your velocity positive? Which means, when is the object going this way? The second one is, when is it going this way? Now to find out where it's going, which direction, you first try to find critical numbers of this, because critical numbers are what changes from positive to negative, basically, or could. So, how do you find critical numbers? You set it equal to 0. Which is kind of nasty without a calculator. Ooh, lovely. That I don't want to mess with. Even with quadratic formula, I don't want to mess with that. And I should have done it before I started, but I didn't. So what we do is set this equal to 0, and we got to find out where that equals 0. Now, could you multiply 3 times 128 and find out when it equals? Complete the square would be ugly because you have a 3 there. Quadratic formula is going to have huge numbers. Let's just do quadratic formula. I should have done this ahead of time. Now, because we need these values, they're pretty important. So, the opposite of negative 40 is 40, plus or minus. Hopefully it works out nice and neat, because I'm pretty sure it does. And then, ooh, 40 squared. And then 100, is that 1,600? Yeah. Because it's 4 squared, add 2 zeros. Minus 4 times a times, ooh, 128. Yes. Could someone get a calculator out for me? Divided by 2 times 3. So, we now have 40 plus or minus the square root of, okay, that's 12. 12 times 128. Anybody got that? 1536? Ooh, all that stress for no reason. Is that 36?
64.
In the end, that will become 64? Yeah. Okay, good. Yeah. But, okay. So this right here, nice and neat. So it comes out nice. It was really big numbers. Scared me for a sec. But it looks like it's going to be 40 plus or minus the square root of 64 over 6, which is 40 plus or minus 8 over 6. Okay. Not as bad. Look kind of like it could be worse. Okay. So 48 divided by 6. 8. And then 32 divided by 6. So it's 8, and then 32 divided by 6, which is 16 divided by 4, which, what?
5 1/3.
Is it 5 1/3?
Yeah.
Okay, it would be 5 1/3. So we got that and that. Yeah, 5 1/3. Good job. Okay, what's important about those two spots? Those are when your graph is going to change directions. With your, not graph, yeah. Your velocity is going to change directions. So what we're going to do, to find all 3 of these questions, you actually need to make a little table. Make a little table here. And for the first one, we start with 0. By the way, do we include 0? Yeah, because we could talk about at 0 time. So we include 0. And we go to, which one comes first? I think 5 1/3. And then we're going to go from 5 1/3 to 8. And then we're going to go from 8 to infinity. Those aren't coordinates. I know I hate them, but I wrote it this way because it's easier to write. It might be easier to write it in other forms. Okay, if we want to see where it has a positive and where it has a negative, don't you just basically plug a number in this interval into which equation? The velocity. People all the time plug it into the original. So we're going to plug 1. And do we care exactly what the answer is? No. All we care is my answer what? Positive or negative, which is nice. Looking at these numbers, is it pretty obvious it's going to be positive?
Yeah.
Which that means it's going which direction? Would that mean in this situation it's going that way? Because it's positive velocity, tells you which direction it's going. Okay, the next one, what number is nice? Probably 6. 6 or 7, doesn't really matter. Let's just do 6. This one looks like it's going to be minus 240. This one becomes 32 times 3, which is, 36 times 3, which is 100 and something.
Not enough. It's
108.
Becomes 108.
Yeah.
It's going to be negative.
Kind of looks close, doesn't it? Does it make it?
Nope.
Is it negative?
Yes.
This one stays negative. It looks. You had to check that one. It wasn't obvious because you kind of got to make sure it's not gonna. These lines don't always mean it's gonna change. They most likely will. It doesn't mean it. So negative means which direction? To the left. And then you want to plug in 8,000 here. Might be easier to plug 9 or 10.
10.
You could just plug in a really big number. 10 is probably easier than 9 actually. And when we plug that in, looks like that's going to be negative 400. And this right here by itself is what?
No.
Oh,
The answer.
that's 300. So can you tell it's positive?
Yes.
Let's go in this direction. Okay. All that means, well, we go up here. Where is it going? So where are the velocities positive? From the interval 0 to 5 1/3. Correct? And then from 8 to infinity. Now, why are these open brackets? Because at those points, aren't they 0? Isn't the velocity 0 at these points? So this one is closed because 0 counted. Because wouldn't this normally be to negative infinity? But in this situation, we're not talking about negative time, but we can talk about 0 time, where we started. Okay, and when is it less than 0? Well, wouldn't that be this one? From 5 1/3 to 8. And again, it's not a coordinate. If you want to write it in the other form, you can. So that's negative, that's positive. Our graph, our table down here gives us a nice little picture. So where does it change direction? Well, change of directions are at critical points, if it changes from negative to positive or so forth. So does it change here? Yeah. Does it change here? Yeah. Because what happens at each of these points, you understand the velocity is 0? So it stopped. Do you guys understand to change direction you have to stop at some point? Try to turn around but never stop your car. It's kind of impossible if you're going perfectly side to side. If you're turning, you can do it, but we're talking about perfectly side to side. So where does it change direction? When t equals 5 1/3 and when t equals 8.